Welcome, everyone. Nice to see many of you have come to this talk. I'm Alex. I'm a machine learning engineer at ZenML. I'll talk about that in a little bit of a second. My focus at ZenML is working on GenAI and kind of the LLM domain. I help customers build out their use cases, and I also do a bit of kind of research and kind of R&D of just trying out things that are happening and new techniques and so on, just working to understand the space, see what the patterns are, as I'll be talking about mostly today in this presentation. So today is mainly kind of a whirlwind tour of this database that I helped put together. We'll talk a little bit about the challenges of production, doing things with GenAI, particularly large language models in production. We'll talk a little bit about what patterns seem to work, which ones don't, and then I'll kind of tie things together by talking a little bit about evaluations and how this helps make things more robust. So now I'll just share my screen. Okay, please do shout at me, someone, if this doesn't work. Okay. So firstly, just a little quick overview of ZenML, in case you haven't heard of us. ZenML is an open source machine learning or MLOps framework. We handle both MLOps and large language model or LLMOps use cases for engineers, basically scaling AI just beyond prototypes. Our kind of core focus is or was for a very long time kind of traditional machine learning, but a lot of our customers we've seen have shifted over to doing things with GenAI workflows now. ZenML is a kind of a Python interface, think of it, that allows you to define pipelines and run your workloads across any different infra stack that you want. These stacks are made up of a bunch of stack components. And it comes out of the box with data versioning, full metadata tracking, a whole bunch of other things, integrations to I think by now over 60 different kind of flavors of stack components. I'm not going to really talk about it too much in this presentation, but do check it out. A lot of people like what we built and find it useful. But yeah, I'm just going to jump into what we came to talk about today, large language model things. So the evidence base for this talk is this thing, the LLMOps database that I helped curated. It has over 640 different use cases. It covers basically all industries, perhaps, even including government. So from finance, healthcare, education, and of course tech. A lot of the kind of early adopters for large language models have been kind of the tech sector. And it's basically a whole bunch of different use cases taken from blogs, talks like this one, YouTube videos that go up. Most of them are positive. Generally speaking, companies don't like to advertise their failures, with a few exceptions. But yeah, this is kind of the evidence base, things that I've been reading and putting together, just to see, what are people doing when they're, creating kind of serious examples of serious workflows using GenAI in production for their customers or for internal use cases. So let's dive a little bit into the details. I'm sure many of you are familiar with kind of enthusiasm from senior management in companies, or even grounds up enthusiasm to build like GenAI little prototypes. And it's one of the great things about this amazing new technology that we have. It's very quick to build kind of a little POC prototype. Everything looks great. It covers, 80% of what we want to do. It's pretty easy to build impressive demos using off-the-shelf models, basic prompts, and if you use one of your frameworks, it can be even faster. But there's a lot of hard stuff that follows. One big bank in the database did this with GPT-4 and built a kind of a little RAG chatbot, and they had a prototype ready in a few weeks. But actually, the launch and the full rollout, they imagined it would take 3 months, but a year later they still hadn't rolled it out because they kept on finding bugs or edge cases and so on. So going from this like 85% all the way up to 99.9% reliability, everything becomes exponentially harder. So why is this? There's a bunch of kind of key challenges in production. Firstly, non-determinism, the fact that you get different answers out from models every time you query them. This is something that engineers, particularly ones who aren't familiar with like the machine learning domain, aren't particularly used to when testing and debugging things. So that makes it hard. Reliability and cost. You can quite easily have huge issues with spiraling LLM costs when you run things in production. And there's reliability issues, getting timeouts from your model providers, rate limits. All of this stuff is hard. In terms of testing, some of this relates to the non-determinism. Some of this relates just to the fact that as these workflows start getting more and more complex, it becomes harder to run these things end to end, certainly in a repeatable or reproducible way. And there are many examples in the database of companies who mentioned that they were initially doing this kind of like vibes-based deployment, but eventually they had to mature their setup to get a handle on this. And then in terms of the workflow orchestration, we're talking about like how to handle things at scale. Sometimes you need kind of real-time or near real-time responses, particularly for these kind of chatbot type use cases. And you might just have like incredibly high loads as well. And so we had one example in the database from Gradient Labs, a company. They had to develop their own special kind of execution engines to handle all of their production conversations load. And there's some regulatory obligations as well, particularly since early February this year, with the AI Act coming into effect, or at least part of it. There's kind of different grades of obligation, but there are pretty tough documentation requirements if you fall into the high-risk category, covering model lineage, training data lineage, needing to provide evaluation metrics, risk assessments, and so on. And even if you're in the lower categories, you still need docs, lineage tracking, and so on. Luckily, compliance with the AI Act is actually, there's a very good overlap with good LLMOps or MLOps practices. Version control, eval frameworks, documentation of what you're doing. All of these things will actually help you, in terms of making your systems more reliable, more compliant, but also just, more debuggable. So let's just get into a kind of, what are the teams doing to address these challenges? So there are some kind of general high-level principles that came out of the database and the use cases. Firstly, companies really would do well to start with the problem, not the technology. So first asking the question, do you need GenAI in this use case? Do you need large language models? Could you do it with a smaller model? Could you do it with an older technology? Usually, if you're doing it with something that is a little bit older, it's a little bit more reliable, often can be more reproducible, more testable, and so on. And if you're doing this at scale in production, that's something not to be turned away without thought. Secondly, keeping it simple is really important. Makes things easier to maintain. Complexity, adds more non-determinism in your system, and it can make things really hard to figure out if you have a lot of kind of complexity in how you set up either the system as a whole or how you set up your particular workflows. Thirdly, companies that build evaluation into their development process from day one seem to do really well and benefit from this. I'll talk a little bit more later on this. And then also, focusing on user value over technical impressiveness. I think at the beginning, since a lot of the kind of end users for these things or the first users of this technology have been tech companies in the tech sector, there's been a bit of a tendency towards technical impressiveness. But in the end, users want reliability, they want speed, they want correct answers. They don't really care which model you use, not particularly. And then in terms of like documenting and tracking everything, obviously this helps with legal compliance, it helps debug, helps you work among a team, helps handling kind of version control, experiment tracking, and so on. These I'd say would kind of the foundations. And at a lower level, there are some kind of like workflow patterns that people are using. Workflows are kind of one of the more common things that we've seen in production, particularly around large language models. This is a diagram from a really great paper from Anthropic called "Building Effective Agents." That if you haven't read it, you really should read it. But basically, kind of one of the cases they make there is probably you don't need these kind of fancy "quote unquote" agentic workflows, let alone ones that involve like multiple agents talking together and so on. And in production use cases, in fact, in the database, those kinds of workflows are pretty pretty rare to find. When you do find them, it's often kind of more of a marketing exercise than it is kind of a core part of a particular company's value proposition or what they're doing with large language models. So these patterns involve things from like sequential workflows. So you can think of RAG or batch workflows, whether it's document processing or things like that. You can have kind of branching workflows, which are where the activity or whatever the particular pipeline that you're working on passes through different branches based on confidence, other criteria, and so on. And this is a really common one that helps make things more robust because it's a little bit more testable in that way. Then you have some kind of feedback loop workflows, although with feedback loop, we're already kind of branching a little bit into the side of, particularly when it's automated feedback loops, where things can start going wrong quite easily if you don't have ways of rolling back from these kind of automated feedback loops or stepping out of the loop if it's spent too long in that particular loop. And then you have kind of batch processing workflows, very common in healthcare, finance, government, lots of different domains. So yeah, these are kind of simple architectures or simple patterns. They're relatively easy to monitor, test, maintain. There's a clear boundary between components, and you can kind of optimize each part separately. But when we talk about components, what are we even talking about? So these are kind of building, you can think of it as kind of a building blocks approach, where you have modular components. And there are starting to see, or we are starting to see some kind of modular components come out now. Think of data ingestion, so how you process documentation, and so on. That's a pretty common one. Thinking about how you handle prompts, prompt templating, how do you handle the versioning of those prompts, as well as the documentation that relates to those prompts, why they were constructed in that way. The idea of kind of model interfaces and API gateways. So this is kind of an abstraction to switch out different large language models, or possibly even to route between different large language models, depending on some particular criteria that you specify, or perhaps if one fails, then it can go to another. That's, as I said, that's a pretty common one. Output validation is also a pretty important one. People want to know that the things they're getting back from the large language model, that this is kind of repeatable or reproducible in some way. And so there are various tools to help with that, ranging from the kind of pretty common use of Pydantic as the library for handling this, all the way to kind of guardrails, and then on to kind of collecting feedback even as part of what's the things that are coming back from your output. And then a kind of the meta process level, you kind of have your test harnesses, your evaluation harnesses. All of these things are also kind of components that are part of the mix. But beyond that, it's kind of, we're not talking about just the components. These aren't the only things that your engineering teams and so on would be working on. There's kind of actually a higher level to think about the work that you have to do when you're working on large language models, and that we saw in the database. And this is the idea of kind of like the inner loop versus the outer loop. So the inner loop is the things that I was just talking about. It's component level technical optimization. This is the day-to-day work of engineers around the world. But there is also this kind of like outer loop, which is perhaps the persona of a product manager or so on, someone who's a bit more involved in the working on the product is more involved there. So this is system level improvement based on kind of real world improvement, real world performance, as well as user feedback. So Pinterest have a kind of a text to SQL system. And they have this inner loop, of course, which they kind of talk about how they worked on like LLM prompt optimization, improving retrieval for RAG. But then they have the outer loop, which they also tracked, and they had a kind of a system around, which was about tracking task completion rates. So do people actually, continue using the system or copy out the things which they'd got, as well as other feedback. And by focusing on both of these things, as well as the interaction between them, they had a kind of a 20% improvement of their system over time, which brought it from something that was kind of unworkable and unshippable to something that was workable. And so good teams that we saw in the database, they make kind of clear integration points between the two loops. So this kind of often involves shared metrics. So thinking about ways to link the technical improvements to business outcomes, and vice versa. But basically, like the outer loop is telling you what you need to work on, and the inner loop is kind of implementing it in a technical level. But if you don't have the outer loop, then you can just often get lost in just making improvements without knowing that they're driving anything. So how does this work in practice? Evaluations, I think, seem to be a very kind of strong part of that defines the success of many of these systems in production. So it's at the foundation of companies who are doing this well. Most challenges that we talked about earlier, they become easier with robust evaluations. So the non-determinism that we were talking about, it becomes measurable. The improvements or any improvements and changes that you make, you're able to prove it. You know that because you changed this thing, then this improved. The versioning that you do of all of your, your prompts or different ways of engineering your system, this then becomes purposeful, and you can, understand how things relate to each other. And all of the monitoring that you do of your production systems, this again becomes meaningful. So eval first development is the idea that like you should think about your evals and writing these things even before you start the development work. So thinking through what are the flows of the user, what are the kind of the points at which we could evaluate something. And for workflows, the ones that I was talking about earlier, you can think of workflow completion rates. You can think about how things transition between components. You can talk about end-to-end latency, perhaps, or how does the system recover from failure? But basically, as part of this, you're going to be working on creating data sets for your evals. And it might seem slower at the beginning, but you actually are a little bit faster because you know what you're doing is working towards a goal. You know that it's optimizing something that's going to, eventually tie into some kind of end improvement for the users, if it worked, that is. And yeah, it avoids kind of busy work or kind of the tendency to work on things that are disconnected from the real business value. So let's look at the component level that we were talking about earlier. What are we talking about here? So there's a whole bunch of different evals, and evals is kind of a whole field in itself. But we can think about, in the domain of retrieval, we're thinking about, are we finding the right thing from our whether it's a vector database or just a kind of a Postgres database, are we finding the right thing? Are we putting the right things into the context window to send them to the LLM? Is it actually useful? Are our answers good or correct? There's a lot of examples in the database of people building a system measuring how the information is preserved between the input and the output. For some like financial and healthcare use cases, this might be really important that your system isn't making things up. And then, of course, yeah, the whole idea of hallucinations, making things up, factual consistency. There's a really good example, you should check it out, around financial fraud detection from NICE Actimize, where they kind of made sure that their system focused extensively on making sure that their system didn't generate anything outside the provided context. So yeah, all this stuff you don't build overnight. This is stuff you grow over time, kind of like unit tests as your code base grows. Yeah, there's lots of different ways that this might happen. Slack themselves have a use case in the database where they started with kind of vibes, kind of manual testing. Then they moved to kind of a 3-tier approach. with A/B testing in prod and so on, automated hallucination, as well as detecting kind of formatting differences in terms of the output. And they had special retrieval quality metrics for their search. And all of these things ended up kind of driving the development process rather than kind of trailing behind it. And because they had a kind of component-based architecture, this allowed them to evaluate things separately while also measuring the kind of performance metrics that they were interested in. So as we wrap up, I just wanted to give a few takeaways. Some of the tiles in this image, these are kind of a bunch of blogs that we wrote, which are kind of topical syntheses of things around RAG or security or agents and so on, taking out the lessons and giving a bunch of examples from the database, because there's a lot of entries, so we kind of wanted to give you a different entry point into it. So do check that out if you're interested. One thing that we were talking about just now is just this gap between the demo that you build and production. And this gap is where most projects are failing. So if you plan from production realities from day one, and you focus on reliability, cost efficiency, and maintainability over flashy features, you probably be headed in the right direction. Secondly, evaluation is kind of the foundation of success, it seems, at least from the real world use cases, and we've seen this with our customers as well. Building evaluation frameworks before you start building your application, as well as kind of defining clear metrics up front, and then automating your evaluation, making sure it's continuous, it's tied into your development workflow. This is really important. Keeping things simple, both architecturally, conceptually, and so on. This helps keep your system robust in production, and ideally, people are generally are preferring predictable workflows over autonomous systems or autonomous agents. The data is pretty clear. Like most successful implementations around large language models are using workflow architectures rather than these autonomous agentic architectures. So yeah, rather start with proven workflow patterns, whether it's RAG or batch processing and so on, and then focus on making each component reliable before adding complexity. The dual loop development model that I was talking about earlier, the inner and the outer loop, this is a really good way of balancing the technical parts, technical optimization with the outer loop kind of business improvement, with clear integration points between them, and then also kind of making sure that your team is structured to work in that way. And finally, reproducibility is both a technical and legal necessity. So make sure you're versioning everything, your prompts, your data, your models, eval sets, document all of the decision rationales for all of these things, and build in for regulatory compliance for the beginning, from the beginning, because yeah, this is already here, actually. LLMOps is actually as a kind of nascent domain. It's not actually new. It continues onwards from MLOps, which in turn was continuation onwards from DevOps. All of the lessons from these previous learnings, they still apply around versioning, reproducibility, monitoring, automating your systems. But in the end, a reliable workflow that solves problems is much more impressive than a kind of a complex demo app that doesn't actually solve real world use cases. So the real world the real lesson from all of these use cases, I guess, is just that like solid standard engineering practices become more important with all of these new technologies, not less. So yeah, I will paste this link into the chat in a second once I stop sharing my screen. But yeah, if there are any questions, I'd love to hear them. This link takes you to just a little page with the slides and so on from the presentation, as well as some links to relevant things from ZenML about what we were talking about this evening. Thank you. Let me just take a look at the questions. I think there's a question and answer tab. Okay, one coming in. What kind of metrics are used to evaluate LLM performance? Good question. I think with questions around like the specific metrics, Yeah, let me just paste the link in the chat first. That is the link. Okay, metrics for LLM performance. So it's going to differ a little bit depending on your use case. And in fact, something I wouldn't recommend is kind of the idea of just using a lot of these like evaluation frameworks will give you a bunch of kind of pre-cooked or pre-made metrics, instruction following, factuality, whatever. There's a kind of a bunch of pre-baked ones, but usually what you want is something that's tied to whatever it is that you're building. So and there can be different standards for different things. So for like in the financial and healthcare sector, you really need to make sure that hallucinations aren't occurring. So you might then want to have a kind of a loop, which then checks each individual statement that was made, and then maybe does some web search or something, and removes bits that aren't correct, and so on. For maybe like if it's just internal documentation, kind of question and answering chatbot, maybe you have like a lower standard for that, but you need it to be really fast. So I would say, yeah, it really is. It kind of that depends on the use case. Another question coming in. Outside the usual framework of like prompt engineering, temperature, and so on, what are the best ways to reduce hallucinations? Also a great question. I think a lot of it is basically just going to be like putting things into the model which can help answer the question in a way that reduces these hallucinations. So you can put in quite a lot of information into some of the models these days, and really the more that you give it to go on, the less likely it is to make things up. Also, similarly, if you're putting too much stuff in there, then maybe it can be hard to know which bits to focus on. And if you're not being clear that like some things are, customer chats, so maybe it doesn't have the same standard as like I don't know, some Wikipedia page entry or something. Like there are different kind of valencies to different information. So yeah, but that again is going to be something that you need to solve for your particular use cases. How reusable do you find the metrics across dev to prod pipeline? Any comment on the evolution of the metrics? I think for a lot of kind of workflows, there may be less distinction between kind of the dev pipeline and the prod pipeline, particularly once they start getting more complex. Depending on the different components and the different pieces that you put in there. I would say, like, generally you don't want to have too much of a split or difference because, but there are ways of kind of reliable practices of, deploying things to small amounts of the users to then check that, you're not having too much of a skew between things that you're putting out to your users if it is a kind of a customer-facing use case, for sure. And in terms of like frameworks, final question, frameworks and tools that already modularize components, prompt templating, versioning packages, and so on. I actually, and at ZenML, we're generally pretty often we'd recommend people work to build out things kind of manually without frameworks. There's a lot of complexity contained in frameworks, and a lot of kind of pain that comes, like often with like version changes and API changes. So you can build your POC very quickly using LangChain, LangGraph, one of the usual suspect frameworks. But then once you know what it is that you want to build, then pull out the things that you need, work on building your own. And most of this stuff isn't actually very complicated at all. To build yourself, and then you have control over which bits that you can test and track. So yeah, great questions. Thank you, everyone. And I have a feeling we may be out of time now. So yeah, I just want to say thank you, everyone, for showing up. Lovely to talk to you all. And yeah, do check out the link, and maybe we'll see you around in the ZenML community Slack. Thanks, everyone. Bye.